Everyone, and welcome to our new video. In this video we are going to discuss about the Prometheus architecture. Now it's very essential for you to know the Prometheus architecture from an interview perspective, that because multiple components are creating the Prometheus, so the interviewer can ask you about the different components or the architecture itself. So it's very essential to know and to understand the overall working of the Prometheus as well. Now, Prometheus comes with a sophisticated multi-component architecture which helps in the scalability, reliability, and the flexibility, okay, for collecting the matrices. Now, in order to understand the architecture, it's essential to understand the architecture because of the way how you are going to deploy and manage the Prometheus going ahead. Okay. Now, talking about the architecture, it basically uses a distributed architecture where different components handle the specific responsibilities. Okay, and we have a architecture diagram here which is available on our blog, so you can go ahead and take a look into it more deeply. Okay, and we have shown a complete Prometheus how architecture actually looks like ecosystem. It's a complete ecosystem. It even consists of the application server where they are located like that. And in this case we are considering we have 3 application servers, okay, and which are having their client library installed. Okay, and basically these are going to be pushing the metrics to the HTTP metrics endpoint which has been exposed, and this is where the Prometheus is going to scrape those metrics from. Okay, and now this is where the first component, and which is actually the heart of the overall Prometheus itself, known as Prometheus Server, comes into the picture. Now, Prometheus Server, if you look, this is basically a central component, okay, which is responsible for the data collection, okay, storage and querying. Now, these are the most important thing because we want to collect all the metrics that we get from the different systems. We want to store it and query the same metrics to understand how our systems are behaving. Okay, so the 3 main subcomponents are retrieval engine. Okay, this is also known as scraper, and you will hear this name a lot of times because Prometheus is going to scrape the metrics from the different endpoints, and that's how basically it works on the pull based mechanism. Okay, now the purpose is it actively pulls metrics from the configured target. Okay, that's the primary use case for the scraper. And if we talk about the functionality of the scraper, it helps in the service discovery integration, so that when you are deploying the service you don't need to redo this stuff again. Prometheus is automatically able to discover and pull the metrics from that. Then it uses a HTTP client for scraping these metrics endpoint, and it basically uses a target health monitoring and configuration for the reload without restart. Now this is very important, that obviously we don't want to restart Prometheus again and again, right? So all of these things are basically performed by the scraper. Okay, and whenever you are configuring, you are going to pass the scrape configs, that is, you are going to pass like from what is the job name. Okay, then you are going to pass the targets from where the Prometheus is going to scrape. Okay, you can provide your DNS followed by the port number like that. Then you also need to tell how frequently you are going to scrape these matrices, like I can scrape every 15 seconds, 10 seconds, like that. And you are going to pass the path from where this is going to scrape the matrix, that is like slash matrix or something else. Okay, and you also should provide a timeout, considering that if the system is down, then Prometheus is not waiting endlessly, right? It should mark it as a timeout and move ahead. This is also very important. Now, coming down to the second component of the Prometheus server, which is TSDB, which stands for time series database. Okay, now time series database stores all your metrics and data efficiently. Okay, and basically all the metrics that you are gathering, it's basically marking it with the timestamp and storing that data. That's what the time series database really means. Now, what are the feature? It helps in the optimized time series data. Okay, it has a compression algorithms which reduce your storage by 90%. Now this is very important because you are collecting at a very short interval. We do not want to pay extra for the disutilization like that. Then it also uses a configurable retention periods, like I can retain it for 1 month, 6 months, depending upon how a longer term I want to retain. And it also helps in the fast query performance. Okay, now if you look at the time series database, basically the storage structure, it stores all the metrics under the Prometheus data. That's where the directory lies. Okay, and you will see that it has random hex allotted to it, which is like a block directory. Then there are chunks, right? Basically the data chunks which it stores. Then there is an index and a metadata.json which stores all the metadata information, and tombstone basically add a delete marker. So this is like the overall structure, and it stores it on your disk under the Prometheus data. So you can go and take a look over there, and it will show you all the time series database information that it has. Next comes your HTTP server, or this is also like a query API, right? And basically the main purpose of HTTP server is to serve as a promquel queries and the API requests which are coming from the user. So you would be making the request to the Prometheus in order to get the data out of this time series database, and that's where promquel, Prometheus query language, comes into the picture. And this HTTP server is basically responsible for serving those queries and API requests which is coming to the Prometheus. Now there are different endpoints like /API v1 query, which gives you instant queries. Then you have /API v1 query underscore range, which has a range. You can provide the range to the queries. Then /API v1 series, which provides you series metadata. And then /API v1 labels, which helps you in the labels discovery. So you can mark your resources on the basis of labels, and then you can retrieve those on basis of your labels as well. Okay. All this information is available on our blog, so you can go and read about this post in more detail. Okay, same post, and it will give you all the information which I am talking to you about. Okay, now next comes your client libraries. Okay, we see this client libraries over here within the application integration. Now client libraries instrument our application code to expose the metrics in the Prometheus format. So basically it's the responsibility of these client libraries which we are including in our application. This is basically done by the developers. They are going to include these libraries while writing the application code, and this will help us to expose the metrics which Prometheus understands and is able to scrape as well. Now these libraries from the Prometheus are available for the different languages, like it has Go, Java, Python, Ruby, .NET, Node.js, PHP. So all these are the major programming languages in which the applications are being written. So what developers can do is they can directly use a package like a dependency. If we talk about the Golang, they can use a package resource, and then they can which mentions their the overall code, and then they can directly import these metrics from the GitHub where the Prometheus has written them, and they can directly import this. So when they are going to build up their code, it will directly fetch these libraries from the Prometheus official repositories, and these libraries are automatically able to expose the endpoints like this metrics through which the Prometheus is able to scrape the metrics. Now metrics types, okay, this is very important because whenever you are going to work on creating the dashboard within the Prometheus, you should be aware about the types of metrics which the Prometheus support. Okay, so there are different types of metrics like counter, gauge, histogram, and summary. Okay, so you should remember at least minimum of these, because if you do not understand these metrics, then probably you cannot really figure out what type of graph or how to best show the data which you are getting within the Prometheus. Now if we talk about the counter, it's monotonically increasing values. What that means is it's simply like if a value is going up or down, then you can use the counter. Like in case of temperature, it can either increase or decrease, so you can use the counter over there. Next comes your gauge. Okay, and basically gauge can for the counter, it's basically monotonically, right? So that's like a counter. It will show you one count of how many requests are coming. Sorry for that, actually we confused it with the gauge. So within the counter, it basically checks for the increasing values, right? So if something is keep going up only, like there can be some requests, right, which keeps on increasing, and you want to see the count, then you can use the counter directly. Then there is gauge. Gauge is basically the values which goes up and down, right? This is what we discussed previously. So it's basically the gauge. Gauge will help you like in case of temperature, which can either go up or down. So you can create a gauge matrix for that. Okay, then comes your histogram basically provides you observations distributed into buckets. What that means is basically it will show you the different observations over a period of time. Like consider a case of the response time, right? So over a period of time we want to see how our response are performing. In that case we can use the histogram. And similarly there is summary. So similar to histogram we have the quantiles, in which case we can use the summary. It will provide you a brief summary of the metrics which is available. So based on these you can go ahead and use the metrics depending upon what type of metric you are receiving for your application, and the best suited way to demonstrate that. Okay, so these are the types of metrics. Next comes your push gateway. Okay, so if you see there is a push gateway as well. Now as I told you that Prometheus basically works on the pull based mechanism. Okay, but there might be some short monitoring batch jobs or short lived process. Okay, suppose I'm doing some cleanup, so I create a job within the Kubernetes which runs for a very short period of time, and then it runs and cleans up the thing, right? But it's very for a very short period of time. It runs and cleans up and then it stops. Now if I wanted to get the metrics out of it, okay, before my Prometheus could have pulled, might be the job has already stopped, right? By doing his work. So in these kind of jobs we can actually make use of the push gateway. Now push gateway actually help us overcome the challenge where we are dealing with the monitoring batch jobs or the short-lived processes that can't be scraped directly, right? So in those cases we can configure push gateway to send those metrics to the Prometheus. Although this is not the usual way, Prometheus is usually use a pull based mechanism, but this is for a very specific use cases which includes like cron jobs or scheduled tasks which run for a short period of time. Then there are batch processing jobs, then there are CI/CD pipeline steps, or the lambda function or serverless processes which executes over randomly over a period of time, and then basically short lived and it gets closed. So in those cases we can actually make use of push gateway to push the metrics of these into the Prometheus, and it will be visible for us. Okay, now when you are configuring this you can directly call the push gateway endpoint which runs on basically the port number 9091, and you can configure directly over there. So what it will do, it's going to you need to provide the like the target that the push gateway needs to pull, and it's going to directly pull it. Now so basically what's going to happen, there is suppose a batch job which is running. Okay, it will push gateway is directly going to get the metrics from this batch job using the HTTP post. Batch job is going to provide that data to the push gateway. Okay, and then push gateway uses a persistent storage. It's going to set that metrics to the Prometheus so that the Prometheus can store that metrics. Okay, and then comes your exporters. Okay, exporters basically bridge the gap between the Prometheus and the system that don't natively expose Prometheus metrics. What that means is that if there are some systems which do not directly expose the metrics, what kind of systems, like we previously learned about the there is a clients, right? We can include the client library. But what about let's say your server? Okay, now suppose I wanted to measure the memory, CPU usage, this usage and network utilization on my server. So I cannot include the library over there, right? It's a pre-built Linux configuration, so I cannot really go and include Prometheus there. So what is the option I am having? In those cases, basically exporters comes into the picture. This is just an example. There are other use cases as well. So you can use this node exporter in this case, and what it will do, it will provide you all those CPU, memory, disk and network utilization metrics which you might be needing. Okay, similarly is the case with the MySQL. You can use it for MySQL also. Okay, and things like this. Next comes your alert manager. Okay, now what is this alert manager? Alert manager is basically an intelligent alert handling. Okay. So alert manager basically receives alert from the Prometheus server and handles the notification. That is, it helps in routing rules. Okay, then it also helps in grouping of the alerts, and notification, like silencing them. Okay, so if we talk about like routing rules, where do we want to send those alerts to? Like might be different Slack channels, or different if you are using Opsgenie, to different teams and groups like this. So we can go ahead and configure those types of routing. Then comes your silencing. Silencing basically comes like we already acknowledge the alert is going on, right? What if we now want to go ahead and it will take some time for us to resolve. We don't want to create unnecessary noise. In those cases, we can go ahead and silence the entire group. And notification channels, it will send out to the different notification teams and stuff like this. Okay, considering the routes, okay, let's take a alert routing in more detail. Suppose I'm whenever I'm sending the alerts, I can say that if the alert is coming from my database, right, then database alerts should be critical, and receiver would be, suppose, pager duty. So what it will do, it's going to route this kind of critical alerts to my pager duty, so that I'm actually able to take a action at a earlier stage in time, right? Now, if suppose the alert is not so critical, okay, in that cases we might just route the alert to some Slack group, and probably we can take a look at later, right? So these kind of routings we are talking about. And when we talk about group, we can group several alerts together which is belonging to a, suppose, a particular application. So suppose if different servers, okay, which belong to same application, we can group them under one group like this. And this reduces your notification noise, because now it will not send out like huge number of notification for each instance and stuff like this. Okay, so we can group them, which helps us reduce the noise, and we can configure the grouping criteria based using the alert grouping. And silencing is basically when we are basically receiving too many alerts, we can silence it out till we are taking the corrective action like that. Okay, now notification channels we already discussed, like we can send out to Slack, PagerDuty and stuff like this, to different notification which are available. Okay, now if we take a look at, since we already discussed now all of them, okay, so Grafana is basically for the visualization, right? So all the data that we are getting, if we wanted to plot all these graphs and etc. over the Prometheus, all the Prometheus has built in, but Grafana is more like it's basically used more commonly with the Prometheus, because it helps you create a dashboard where you can group different different graphs or the metrics together into the same dashboard, which shows the overall system health, right? And so that's why you will see that we don't necessarily use the Prometheus inbuilt dashboards, although it has the capability to provide them, but we do use Grafana instead, which has better visualization. Okay, so how does overall data flow looks like? Okay, so basically your application which are having the client libraries, they are going to expose this slash metrics endpoint which you see here, right? And then Prometheus server is going to scrape those slash metrics endpoint, and that is being sent to the alert manager. Okay, now once the metrics are within the Prometheus server, you can actually see them within the Grafana dashboard, or the alert manager can send out the notification to the notification channels that we are having. Okay, so alert manager will run some it will run some conditions which we have pre-configured. Suppose we said that CPU utilization more than 80%, then send out the alert to the Slack channel, right? So it will do that kind of maths and basically send out the alerts to the notification channel. Now from the Prometheus server, we are directly going to see the dashboard within the Grafana. Okay, and then basically it sends that request. Like we can again send. We can also use the exporters which are there, and exporters can send to the Prometheus server. Okay, and these exporters are basically going to send for the batch short-lived jobs to like Pushgateway and Pushgateway can send to the Prometheus server. So that's how basically your overall flow looks like. Okay. Now, if you look at metrics generation, we are having the application which exposes the metrics using the client libraries. Okay, and basically exporters can use the third-party system for this metrics, and push gateways basically for to receive the metrics from the batch jobs. Okay, then all this metrics collection is basically handled by the Prometheus server, which scrapes from the target, and service discovery is automatically finding the newer services. Metrics are basically stored inside this TSDB storage. Okay, for query and visualization, we are basically relying on the Grafana, and we can run the ad hoc query on the Prometheus web UI also. So learn that there are two UIs, one is Grafana and one is Prometheus. Usually we run queries from the Grafana, create all the dashboard, everything from the Grafana, but it's not limited to Grafana only. Prometheus also provide you a dashboard, so you can go there and directly run your ad hoc queries as well. Application can query metrics programmatically from the Prometheus. Okay, and for the alerting, we already have the alert manager which sends out the alerts. Okay, now for the deployment patterns, we can go ahead and deploy Prometheus as a single instance, and we can also have a high availability deployment in which we can create more than one Prometheus and configure the alert on them. Okay, so that we are going to discuss in ahead. Okay, about the high availability of the Prometheus and stuff like this. So that's all for the Prometheus architecture that you should be knowing, and the few of the metrics and how the overall system actually works. Okay, so if you just have to group them at a very lower level, just remember there are basically three layers. One is your Prometheus server. Okay, one is your alert manager, and last one is comprising of your exporters, push gateways, and Grafana. Grafana is your visualization layer. Okay, and this push gateways are basically nothing for short-lived jobs, and exporters is for exposing the metrics from the application directly, which Prometheus can scrape. So basically three layers are there: Prometheus server, alert manager, and Grafana. Okay, and if you are remembering them, then most of the stuff you can easily convey within your interview. Okay, so this is very, very important from an interview perspective. If you have not go through this, I have covered all the major details that you need to know about the architecture, and I have included some examples also for you, so you can easily understand and answer all these questions related to Prometheus architecture. So that's all. Okay, for this video. I will see you in next video. Thank you everyone.